Hi guys, my name is Edwin Alejandro Tapias Pulido. On this day, I am going to talk to you about of strange abrasion and penetration characteristics of cement concrete contain discarded rubber fine aggregates. Abstract: the elimination of solid waste in the worldwide problem. If these are not disposed of properly, these materials become sources of environmental pollution and related problems. The article investigates the suitability of wasted dry rubber in cement concrete and a partial replacement for natural river sand. And you will be exposed to test such compression friction resistance to abrasion. Introduction: concrete is a mixture of cement aggregates and water where almost 70% of the weight of concrete constitutes aggregates, with the exponential increasing on the industry in vehicles a lot of tire and of waste. Edwin and Sinucci were the first to study the aggregates derived from the tires used in 1993, replacing the fine aggregates with used tire rubber. They replaced the fine aggregates with tire rubber discarded between 1 mm, 6 mm, 10 mm, 25 mm, and 8 mm. The elimination of the mechanical properties distributed throughout the adhesion between the rubber surface, the particles, and the cement matrix. Materials properties and preparation of test specimens. Raw materials. In this table we can observe the properties of the material and the preparation of the test sample. The three raw materials that were used were ordinary Portland cement grade 43 with a specific gravity of 3.15, normal consistency of 34%, initial settings time 99 minutes, completion time 176 minutes, natural river sand, specific gravity 63, humidity resurface 1%, modulus of fineness 2.83, and the thick aggregates were the 10 mm in size with the modulus fineness of 5.573, size of 20 mm with modulus of fineness of 7.312. Stone cruised with a specific gravity of 2 times 16, 3 is also used. Particle size distribution. Particle size distribution of the aggregates, coarse aggregates, fine aggregates, and crude rubber. You can see in the figure instead in percentage on the size. You can see that the rubber power goes to the first levels until to reach the parameters. This being the fine materials compared to the fine aggregates of 10 and 20 mm. Preparation of specimens. In this table you can see the concrete properties fresh for the water cement ratio of 0. and 0.5 respectively. Compression resistance test. In this table we can see the resistance to compression in megasticks of the percentage of tire dust for the ratio of water cement 0.4 and 0.5. For the test sample were taken on a 7 days and the other on 28, where it was noted that the lowest amount of tire powder, the greatest in the compressing strength, was also associated with the resistance with the sample of 28 days, so it was for the water cement ratio of 0.4 and 0.5. Flexural strength test. In these tables we can observe the resistance to bending in megastibs on the percent of the tire dust. For the ratio of water semen of 0.4 and 0.5. For the test, two samples were taken, one for the 7 days and the other for the 28. Where these was noted the last amount of tire powder. The major is the resistance to bending. It was also noted that the resistance with the resistance sample of 28 days. So it was for the water semen ratio of 0.4 and 0.5. Abrasion resistance. In this table you can see the abrasion dip in millimeters on the percentage of tire dust. It can be deduced that this smaller amount of plastic powder, the greater the abrasion dip, being the water semen ratio of 0.5, the one of greater dip, the ratio of 0, and 10, the one of 0.5. Water permeability test. In this table you can see the dip of water penetration in millimeters on the percentage of tire dust. It can be deduced that the greater amount of tire dust, the greater the dip of the water penetration, where it can be noted that for the water semen ratio of 0.5, it is the one that allows more water passage through the material, followed the dip in 0.45 and 0.4. For the absorption B sortivity method. The method is used to determine the rate of water absorption in concrete of hydraulic cement, by measuring the increase in the mass of specimens resulting from the absorption of water as a function of time when only one of the surface is exposed to the water. Results and discussion. The density of the concrete decreased with the increasing percentage of rubber crumbs in concrete. From the results of the flexuring strength test, there was decreasing in strength as the percentage of rubber increased. From the results of the abrasion test, it was observed that the rubber concrete showed a better resistance to abrasion than that of the control mixture. Conclusion. Experiments were conducted to study the suitability of discarding rubber, in particular an abrasion substitute for natural driven sand. And the concrete grades cement ratio 0.4 were 0.00 of 0.45 and 0.5 were also studied. 0.20 percentage fan substitution added in multiples was made with chrome rubber. Samples were taken with 0% tire rubber as a control mixture. Tests were performed to determine the compressive strength, flexury, abrasion resistance, microstructure, water permeability, and sortivity in concrete specimens. The following conclusion can be drawn from the study. It was observed that rubber can be used for the partial replacement of natural fine aggregates up to the 7.5% with sufficient reduction in the dressing strength. The rubber-seated concrete can be recommended for the construction of pavements, structural walls, and non-structural works. Thanks.